Okay, let us start with the lecture. In today's lecture, we are going to discuss about the fourth type of minor irrigation scheme, that is the lift irrigation. So when we talk about minor irrigation scheme, then lift irrigation scheme may be a minor irrigation scheme or it may be a major irrigation. Now, up till now, it is clear to you that minor irrigation scheme cover a small area. So minor irrigation, lift irrigation as a minor irrigation scheme, we are going to discuss a small lift irrigation scheme which will irrigate a very small area. Opposite to that, in major lift irrigation scheme, the area to be irrigated is very large and also it covers the greater command area. So there are two possibilities in lift irrigation scheme. It may be major or minor. Now we are going to discuss this point with respect to the minor lift irrigation scheme. So when we say a lift irrigation scheme, then we have discussed in types of irrigation. Lift irrigation scheme is implemented when the point of delivery, that is the command area, is at higher elevation than the source of water. When the source of water is at lower elevation and the delivery point is at higher elevation, in that case, water needs to be lifted through a rising mains. So there is a need of pump house with suitable types of pumps, with suitable capacity of pumps, and that water should be lifted by means of pumps to the delivery point or delivery chamber. So this particular sketch shows one such a lift irrigation scheme, which is called as a Gosi-Kurd scheme. So here the water is lifted from the reservoir through the pumps. It is then conveyed to the delivery chamber through the rising mains. Okay. So this is how the lift irrigation scheme is planned. Now this lift irrigation scheme does not only lift the water at higher elevation, but also it supplies water to the needy region located far away from the source. So this statement is true in case of the large lift irrigation scheme. Now in Maharashtra, there is a second largest lift irrigation scheme of India, and that is called as a Tembu lift irrigation, which taps the water from the village Tembu near to Karad, and it supplies this water at high elevation at various points in Sangli district as well as Solapur district. So a large area is covered. So in that case, it is a major scheme. Now, this lift irrigation scheme is also used to feed the tanks for future needs. Now, suppose some drought-prone area is there where there is a scarcity of water. In that case, these feeding tanks are filled with help of the lift irrigation scheme, and the need of water in case of scarcity in case of summer season can be fulfilled. So here in lift irrigation scheme, there is an optimum utilization of water because here water needs to be lifted. In flow irrigation system, there is no power requirement to supply water to the command area. But here there is a need of power requirement, and that's why its cost is higher, operating cost is higher, and that's why the cost of irrigation water is also higher. So the water use is limited. So that is the meaning of optimum utilization of water by supplying designed quantity. Lift irrigation schemes are also required in interlinking of river projects. Then they are also required to transfer the surplus water from reservoirs to the required regions. So these are some of the objectives fulfilled by lift irrigation scheme. Now we are going to discuss about how the planning and design of lift irrigation scheme is carried out. So these are number of steps which are involved in planning and design of lift irrigation scheme. The first step is the study of hydrology. Okay, so we have studied the 3 chapters on surface water hydrology, and we know what is the scope of the engineering hydrology. We know that in hydrology, we came to know what is the yield of a particular catchment. By making use of this particular information, lift irrigation scheme can be planned. Second is to fix the alignment for the scheme. Third is then deciding the hydraulic particulars, deciding the type of pump, number of pumps, and capacity of all the pumps. Then to design intake structures, surge, pool, and forebay. Then next point is design of pump house and pressure mains. Then installation of surge protection system. Then construction of delivery system or outfall structure. Then supervisory control and data acquisition system, that is a SCADA system. And then last point is a canal networking system. When water is delivered in the cistern, water is delivered in delivery chamber, which is called as a delivery system, or it is a outfall structure. And after that, water is conveyed to the command area by the canal networking system. So these are various steps. Now we are going to discuss in detail about all these steps. So the first is hydrology. So in the study of hydrology for lift irrigation project, at first the crop water requirement is calculated. Now our last unit is the crop water requirement. In this, we are going to discuss how the capacity of reservoir is decided based on the crop water requirement of various types of crops considered in a command area. During this design, the designer also should have considered about the seepage and evaporation losses. Here the water is conveyed from the source to the delivery point and then to the command area. So during this journey, the seepage is there and evaporation is also there. So these losses should be accounted in order to find out the total quantity of water required for the crops. When the lift irrigation schemes are planned, they are also planned for drinking water requirement. Along with the irrigation, they fulfill some other purposes like drinking water requirement. Then during this hydrology, the operation period of pumps should be considered during the study of hydrology. Then low water level at the source should be above the bed level of source. It should be above the maximum drawdown level of reservoirs at river intake. Okay, maximum drawdown level is the minimum level of water in the reservoir at a river intake. Then for pump houses far away from the source, conveyance losses shall be deducted from the lowest water level or maximum drawdown level of this. Now, while fixing the alignment, these points are considered. So this alignment is the alignment of the rising main, also the alignment of the canals. So related to alignment, alignment also consists of fixing of the location of pump house. Then approach and gravity canal length, lengths of the pressure mains. Now, what is approach canal? Approach canal is a canal which is constructed from river to the sump house. Okay, sump house is the bottom portion of pump house, and here the approach channel is constructed from the river to that particular pump house. And when the water is delivered in delivery chamber. Then there are the gravity canals. So fixing the alignment of approach channel and alignment of the gravity canals is included in this particular step. Now, when the water reaches to the pump house, then through the pump house, the water is lifted. And this water is lifted by means of pressure mains. Pressure mains are the pipelines. Okay, it may consist of one pipeline or combination of two, three pipelines. So these pressure mains are called as the rising mains, through which the water is lifted from the sump well to the delivery chain. Utilization of tanks in route the alignment. When the lift irrigation scheme is large, in that case, from the delivery chamber, the gravity canals are constructed towards various tanks in the lake. So fixing their alignment is also a step in this particular point, total alignment of lift irrigation schemes. Then number of lifts and pump houses. So these are also decided in this particular step. After that, the location of pump house. How to decide the location of pump house? So the pump house should be close to the source so that the length of approach canal is small. Then length of approach bridge is small. So approach canal is what? It is a canal constructed from the river to the pump house. Then length of pressure mains. So pressure mains or rising mains may be shorter in length. Okay, they should be shorter in length. And if they are longer in length, then it increases the capacity of pumps, so which results in increase in the capital cost. Also, if the length is longer and pump capacity is higher, the thickness of pipe required is also large. And it also increases the operating cost. So while selecting the length of pressure main, care should be taken that this should have the shorter length so that it will affect the overall economy of the project. Balancing reservoirs. So balancing reservoirs are the reservoirs which are created in between to make the scheme economical as well as efficient. So for that, some precaution should be taken. In that first is design discharge of pumps can be reduced, which reduces the pump capacity, pipe diameter, and canal size. So if there are in between balancing reservoirs, then the design discharge of the pumps can be kept low, which results in the reduced pump capacity, pipe diameter, as well as the canal size. In the balancing reservoirs, flood waters can be stored and better synchronization of lifts or to make the lift irrigation project as a multiple or multi-stages lift irrigation project, balancing reservoirs are useful. Now see that Tembu lift irrigation scheme is having some balancing reservoir. So water from the Tembu village is lifted to one higher point, and through that delivery chamber, then water is supplied to the first balancing reservoir. From that, the second stage starts. From that balancing reservoir, again the water is lifted to somewhat higher elevation, and there is a other balancing reservoir. From that, third stage starts. So these are the balancing reservoirs, okay, which reduces the overall cost of the project. Due to availability of such a balancing reservoir, the design discharge can be reduced so that all other things will be reduced. Now, number of lifts, as I have said that if it is a small lift irrigation scheme, in that there is only one stage. Means in one stage, water is lifted from the source to the delivery point or to the command area. But if the length of canal is more and if the total head is higher and if there are the command area in route of the canal, in route of the canal, in that case, number of lifts are required. Okay, in that case, project will be a multi-stage project. Then number of pumps and pump houses, they depend on what is the capacity of pumps worked out, what is the suction lift. Okay, there are two lifts. One is the suction lift, that is from the minimum drawdown level to the pump house level. And second is what? It is a delivery lift. So suction lift should be smaller as compared to the delivery lift. And what kind of pumps are used? So based on all these 3 points, number of pumps are decided. Then capacity of pumps. The pump capacity is worked out in HP with the formula 9.81 Q into H upon 0.746 N, where N is the efficiency of pump. Okay, then H is the total head, total pumping head in meters, and Q is the discharge in cumex. With the help of this formula, it is possible to calculate the capacity of pumps in horsepower. Now, different types of pumps can be used for lift irrigation scheme. Now, the type of pump depends on what is the suction lift and what is the discharge through rising line. Based on these 2 points, different types of pumps can be suggested. In that, first is a horizontal centrifugal pump. So this particular type of pump is used for minimum heads and discharge. So where the total suction lift is less than 6 meters. So in that case, this horizontal centrifugal pump is used. And also the discharge is small. Then second is a vertical turbine pump. Vertical turbine pumps are used when there is a high head and high discharge. So where the suction lift is more than 6 meters and the discharge is up to 10 cumex, or the total head is up to 75 meters. In that case, these vertical turbine pumps are used. And if the head is more than this, let us say it is up to 150 meters. So in that case, the concrete or metallic vault pumps are used. So here the discharge is also up to 10 cumex. And if the high head lift irrigation scheme is there, where head is greater than 100 meters and discharge is also greater than 10 cumex. In that case, Francis turbine pumps are. Now the next point is related to the pressure main. The pressure main is what? Pressure main is a pipeline which carries water under pressure. The water is pumped through this pressure main. These pressure mains are also called as a rising main. And this pressure mains, material used for this pressure main is either mild steel pipes or it may be a precast concrete pipes. So either of these two are used. So the desirable limit for velocity through MS pipe is 2 meters per second, and through PSC pipes it is 1.5 meters per second. If the velocity is more than 2 meters per second in MS pipes, in that case the length of pipeline should be shorter and thickness of pipeline should be increased. Thickness of pipe should be increased. Delivery system is what? Delivery system is the portion below the outfall structure. At the delivery chamber, the water is allowed to fall freely from certain height. And at the base of this delivery point, this delivery system is provided so as to dissipate the energy of water falling freely from the pressure main, and then that water goes to the canals. So this delivery system shall be designed as a vertical drop weir type structure, as we have discussed in yesterday's lecture. Okay, so after these points, now we are going to discuss about what are the limitations of lift irrigation. So limited first limitation of lift irrigation scheme is it is much costlier as compared to the flow irrigation. Now, in case of any irrigation scheme, the benefit cost ratio is 1. So in case of lift irrigation scheme, this cost benefit ratio is generally higher, it is more than 1. Opposite to that, in flow irrigation system, this cost benefit ratio is less than 1. But although this irrigation water is costly in lift irrigation scheme, but in most of the cases, lift irrigation scheme is implemented when there is no possibility of implementing flow irrigation system. And to supply the water in case of the drought prone area, which are situated at higher elevation, there is no other option than lift irrigation. Then this lift irrigation scheme required the assured flow from the source. Then there is a recurring cost on power bill. Regular maintenance is required for civil structures as well as for the mechanical works. Life of lift irrigation scheme is shorter than the dams and barrages. And here there is a need of the periodical replacement of the mechanical and electrical components. So these are the limitations of lift irrigation scheme. So based on lift irrigation scheme, again the question asked is write short note on lift irrigation scheme or draw layout of lift irrigation scheme, explain its various components and explain its function. So in the answer, along with the first sketch, you have to write all these points in short. Okay, so now in this meeting, we will stop here, and again I will share one more link. So you please join again so that we can start our last unit. Okay, our unit number 5 is over now. That is Introduction to Irrigation Engineering and Minor Irrigation Scheme. This particular unit is over. So again, you please join. I will share you the link.